Hey, hi everybody. I'm Gary Kwong, and I'm a principal of my own consultancy, YG Software. And today I'm going to talk about how we can use Rust with Python. So just put my slides up for you, and
Yeah, yeah, yeah. Welcome, yeah, welcome, Gary. So I'm Sammy. I come from open source Hong Kong, and this our new child to try to do a webinar on YouTube and also Facebook Live as well. And thanks Gary to give a talk to share with us how to use Watch in Python project. So before we go to the presentations by Gary, I will would like to introduce about the open source Hong Kong.
Mhm.
So let me see. Okay, so this is our website. Our website is open source storage case, so you can find the latest uh, events and information on our website. And uh, and and so if you would like to learn more about the open source Hong Kong, so you can check out uh, our websites. And also we have some social network link as well, just like LinkedIn, Facebook page, and Twitter, YouTube, Telegram, and GitHub as well. But usually we will share just like to this webinar on Facebook and GitHub as well. So yeah, so I pass the floor to Gary to share with us about how to use Rush in a Python project.
Mhm.
Yeah. Gary,
All right.
please.
Thank you, Sammy. So I presume a lot of us here know about Python, and of course, we all know that PyPI is an integral part uh, of our development, right? It has almost 500,000 packages available for install. Um, why Python? All right, easy to bootstrap, easy to hire talents, little security issues. You don't have double freeze, buffer overflows present in other languages like C, C++. However, one of the biggest issues with Python is performance. It can be slow. Now, why Rust? Rust is generally good if you code it properly, one of the world's fastest growing languages. Um, it's rated the most loved language on Stack Overflow for 7 years now, um, now being 2023, October, and it avoids classic C, C++ problems like double freeze, assuming you only use safe Rust code. It has cricks.io, which is the equivalent of PyPI for Python, and currently it has over 128,000 packages available for install. So what if you are starting your own project, you are creating a new project for your own startup, and you can't make up your mind as to what language to start in? Why not just be ready for both, right? Because it's always easier to refactor a code base from one language to the other, do small parts, moving small parts over, small functions over, instead of a ground up rewrite in a whole new language, right? So you might even want to be able to fuse AI, deep learning, Python packages, PyTorch, and all that with some other Rust functions in the future, right? So you just have to be ready. However, I'm going to cover some of the caveats with my demonstration later on how to do this. I will have a demonstration repository where you can try this out for yourself. Um, however, a lot of these versions are changing all the time. This is really new technology. Um, the bindings between the two use something called maturin and PyO3, which I will cover. So you just have to keep up with the latest versions. right? So here we use two free and open source technologies called PyO3, Maturin. There are some other binding projects, I think PyBind or something, but you can try those yourself. But the idea is similar, right? PyO3 is actually the project that gives you the Rust bindings for the Python interpreter, and maturin is the one that combines them together such that when you install the Python package, it also compiles the Rust code for you by cargo. All right, so the idea is use as much or as little Rust as you want. You can start off with, being a majority Python, 95% Python, just some small functions in Rust. You could do 50-50 over time as you get better in Rust. And what's the ending result? You decide what works best for you. If it works just like that, then you don't have to move it to 100% Rust. You can leave it be, right? So you get to decide how much you want to get it to be done. So the idea is you'll be able to use both. So you have 500,000 in Python and you have about 130,000. So you add them up together, you have over 600,000 packages at your disposal. You can hire both Python and Rust developers as your company needs. You don't have to worry about security problems that plague the C and C++ world, like double freeze and stuff. I'm not saying that Python and Rust don't have security problems, but several classes just don't exist because of the way the languages are constructed. All right, so here I have some instructions and I will show a demo if you just give me a moment. All right, so can my screen? Yes, my screen can be seen. So this is my open repository, and I will paste it in comments later, or I will just send it over for Sammy to do it for me. Right, so you can follow me as I do this demo. I'm gonna start off following the instructions first because some of it takes time, and as it installs, I can describe what's going on. First thing we need to do is we need to ensure that Rust is installed. If you do not have it installed, just do it on the follow the website. All right, and I'm going to share my terminal window. So the instructions are in that repository that you can follow. All right, so is my terminal shared yet? All right, thank you. Okay, so I have an empty directory here. My Rust is already installed, and I'm just gonna copy and paste the instructions. Right now I'm creating a new virtual environment. Let me just ensure that I don't already have one installed. So I'm just gonna create it again. And I'm going to copy and paste my instructions. And here I'm gonna need to install cargo b install, which is install binary packages of cargo. because one of the features of Cargo is to be able to install packages, and one of the packages gives you code coverage support, which is best installed using a binary package. And I'm just going to keep pasting those commands. And then clone the repository and cd into it. So clone the repository, cd into it. All right, and then this should be the same as my repository. And I'm gonna just copy these set of commands that I will explain right now. So because you've already cloned my code and my code is ready, prepared for you, what this command does is it checks for Rust warnings. These instructions here will install the Python code for us. Cargo tarpaulin will run code coverage while ensuring all of our Rust code tests pass. And then maturin develop will install the packages again while creating a Cargo, kind of like a library that the Python code is able to access in the interim. So this will take a couple of minutes. So while this is happening, I will switch back to my slides. Okay, can my slides be seen? Thank you. All right, so I won't go too much into the detail of the performance benefits. There are a few blog posts on the web. Pydantic version 2 leverages this as well. And if I just open these up in new tabs, you'll be able to see that other people use this, and they talk about this at FOSDEM this year, for example, and that's early this year. There are benchmarks here that show that Pydantic v2 is significantly faster, and v2 leverages PY03, leverages the integration with Rust. These are the Rust bindings over here, and they do have more articles if you so wish to read about it. In particular, this blog post has a lot of the technical details as to how you can find slow paths in your Python code and use Rust and make it faster. For example, you have a naive translation, and you're going to have to sample the slow codes and then figure out how to make it even faster. All right. So back to my slides. I'd like to share how these technologies helped me firsthand. I hit the following Python 3 era Windows only, right? The traceback pointed to this particular line, f.truncate, f.tel, and I got a weird overflow error that happened only on Windows. The same code ran on Linux and Mac without any problems. But for some reason, Windows had this problem, and I was apprehensive to fix this only on Windows because the code was working perfectly, was working well on the other platforms. So I thought this might be related to some architectural issue. So what I did was basically I refactored this truncate function in Rust, and the error disappeared. However, there's a caveat because I didn't do any optimizations. My Rust function with a naive benchmark was possibly 10 times slower because you had to cross the FFI boundary, right? But at least this overflow error was gone. Even if I wrote a try catch Python exception block to catch this, I still have to truncate the file anyway. And if you run the function over and over again, even if it hits the overflow error, your file will never be truncated. So in this case, it helped me directly in this way. In the upcoming demo that hopefully you'll be finished installing, which I think it has, you will be able to use PyTest and coverage, which gives you a testing framework and a code coverage for Python code. You should also be able to use Sphinx, SPHINX, which is the documentation framework to generate documentation from inline comments. You can also use cargo tests and cargo tarpaulin, which is basically the equivalent of test framework and code coverage for Rust code. The linters for Python code are all available: rough, pylins, mypy, pyrite. Most of them are on the strictest possible settings except for pyrite, which is only on basic. I found that typed Python looks similar to Rust code. So Rust is known for being difficult to pick up for beginners, especially its compiler, but its errors are very detailed. You don't need extra linters for Rust code because you have something called cargo clippy, which kind of does a similar thing. And if the code doesn't like it, it doesn't compile. So what's the caveats of this situation? It's very new technology. Right now, it's based on Python 3.10. It should work on 3.11, but I haven't tried it yet. And the newly released Python 3.12 is also up in the air. Even less Python libraries support it right now. My demo does not cover creation of standalone binaries. So if you're asking whether I can use the Rust code to create a standalone library that will encompass the Python code, that's not part of this demo, right? That's part of PY Oxidizer or PyInstaller or something else. Rust is harder to write, as I said earlier. However, safe Rust code should work. It should be safe. If you use unsafe Rust code, then you probably should know what you're doing already. Now, the Python GUI may be a factor if you're going to write multiprocessing code. So it is possible to have the multiprocessing code be in Python and you just write a simple Rust function and you loop over it. However, because the Python GUI is in place and you're crossing FFI boundaries, so maybe probably better to offload the multiprocessing code into Rust. Make sure your Rust code deals with multiprocessors properly, and then run that code from Python instead. So the Python GUI is not tripping over itself, especially since the GUI is going through potentially big changes in the upcoming 3.12, 3.13, where they're talking about a no GUI Python soon, right? On the contrary, the Rust async story is still causing debates. Something called Tokio, Tokio, is the go-to library right now. But as of right now, I think there isn't really a good standard library async Rust story yet. And as I said earlier, whenever you cross FFI boundaries between Python and Rust code, you still need to think about what are your steps, right? Even other people on the benchmarking blog posts, they talk about first creating a naive version and then sampling your code and see what's needed next. And then you slowly optimize your code until it becomes faster than just a native Python implementation. Right, so back to my demonstration. It has finished installing. If we do a listing of the number of lines of Python code in this case is 200 or 113 lines of Python. It has also 113 lines of Rust, purely by coincidence. We can see the tree structure. So in case you wonder, TOKEI and tree were installed from Cargo, all right, from crates.io. It's really cool to see, to be able to see all this in an easy way. All of these Python structures are fairly rigid. It has to be a module name. It has to be within Python. This is explained in the PY03 repository, and Rust code is advised to be also under a subfolder. Excuse me, under a subfolder over here. Right now, I will see if I can open this up in VS Code so we can navigate this a little bit easier. In the meantime, if anybody have questions, please feel free to write about it somewhere so I can answer it at the same time. Okay, so now I have a window. Let me see if I can share it. Okay, let me see that I can share my VS Code window. Okay, so this is my repo, and you can see that cargo Tomo file by default is already there for you. It also has PY project. It has some settings for some of the most popular testing tools, and they're all on the strictest settings. For example, MyPy is on the strictest setting. This is just a personal preference, and likewise, Pylins and Rough has most, if not all, of their settings turned on. Right now, the module is called HK Python October webinar. You should be able to do a grep and change the package to something else, but I would recommend that you reinstall in a new virtual environment. This example over here, this is a Python implementation that I talked about, the truncate function. And here I'm calling the Rust code, which is imported from here, that is defined in src.lib, src/lib.rs, and this is the bridge that crosses the FFI boundaries between the two languages, such that this Rust code is able to be used like a native Python function. The caveat is we're not able to use pylins to inspect the types, but that's possibly changeable with newer versions of some of the libraries that we use in the future. Okay, so what if we try running this? Let me see if I could open a terminal so I don't have to go over. Presumably, I am probably even in the wrong WSL. I have a couple of WSLs over here, so I think I have to change my screen again. In any case, before I change my screen, okay, right now it is running the Rust code. So let me switch back to my terminal. All right, and if I just run the package, here are the messages from native Python functions. However, I do have a function that says this is from Rust, and this is where you see the Rust functions coming into play. I will also show you the truncation of a 23 million line text file, which is basically the Python documentation concatenated a bunch of times. And let me see if I have that in my history so I don't have to retype. So here we're copying it to a local file in this repo, and I'll be counting the number of lines here, and I'll be running the truncate side of things and then counting the number of lines again. And this is the Rust code that's running. Now, bear in mind, this is WSL in a Windows machine, so it might be a little bit slower in that aspect. As you can see, it runs over here. I wonder if I can time the whole thing, right? Well, this is probably not to time the counting of the lines, and I'll probably just time truncate function. And let's see how it goes. All right, 23 million lines. And it gets truncated properly to just a million. All right, takes you about 6 seconds total. Now, if I were to go back to my VS Code, and I'll switch my screen sharing there again. Okay, so this is back to my code. All I have to do is to change this to PY. Oh, sorry, no, that's wrong. I probably shouldn't import that, and I'll use PY that's available here. Okay, there you go. So now I'm using the native Python implementation that has this line that may cause the overflow error. Let me go back and share my terminal again. All right, so if I were to run everything the same way again, this would be faster. All right, so what we are seeing here is instead of calling a Rust function here, I called a Python function here. I know this is slower, but I didn't have an optimized Rust function here, but at least it doesn't hit overflow error in the Python code, even though the Python code is much faster. And ideally, if you hit problems here, if you change too much code, you're going to need to rerun this installation command all over again, just because of the way Python packages are, or a recompile of the Rust code is needed. Whenever you run maturin develop, it recompiles the Rust code again. In this example, I'm only changing something very simple in the Python code. That's why that's not needed. So having said that, if I were to go back to my repo, maybe you'll be asking, oh, Gary, if you said that this you can run PyTest with this, show me. So this is what I will show everybody right now, which is we know that the Rust linters, they work. Cargo Clippy works. I've shown you that this works. I've shown you a truncation example. And here's the example where I run PyTest. So if I share my terminal again, okay, so I'm just gonna run PyTest. As you can see, I have all the settings for multi-core tests being run on Python. It has all these versions. It has all these code formatters and tools and stuff. Later, I'll show you the generation of Sphinx information. Oh, okay, it found a bunch of problems, and I think the reason is because I commented out some things, and that's blowing up in our faces here. So if I just switch back my code to use the Rust function, it should just run properly. While this is happening, I'm going to see if I have more examples I can show. I have not shown the Rust code in the Rust functions yet. So, okay, there you go. You can see that PyTest runs. And likewise, I will generate, probably should hide this. I will generate Sphinx documentation through this script, which is also in the repo. And the HTML files are there, and I will use a text browser to open up the web page, and you can see, for example, the documentation here just works. All right, it has all the type information and stuff. Right, so all this is generated from the Python side. Let's quit this. And let me share my VS Code again. Okay, so here's a look at the Rust code. The convention for Rust code is they have the Rust code here, and the tests are immediately after that in the same file or at the end of the file. So the nomenclature that's being used over here is for cargo tests. The PY function macro and PY result come from the use of the PY03 crate. Otherwise, the rest just uses the Rust standard library. And in samples.rs, you can see the Rust function that says this is from Rust. So another thing to show everybody is, even though this is meant to be a Python project with some Rust integration, so your Python code is the main thing, you should also be able to run the Rust code directly, bypassing most of the Python bits. And let me see where that's being defined over here. Now, in this example in pyproject.toml, you can see I'm not using setup tools. I'm using maturin to do it. And hence, there is a section where it's called project.scripts, and we'll be able to call these functions directly from the command line. So they skip most, if not all, of the Python code to directly run this function on the command line. So let's see that in action. Over in my terminal. Okay, So let's try just running print something. There you go. You can run the Rust code directly. Think about this portion where maturin helps us to put some sort of a symlink into that file. And if I'm not wrong, if I look at hidden files, I should have a file that shows the view. Let me see if I can find it. Okay, there you go. This is the bridge. Right, maturin generates this automatically for us. And this .so file contains the Rust code in the form that Python can import those functions and use it. So let's look at the size of that. Just for information purposes, it's 11 megabytes in this example. Now note that the code being developed here is debug code. If you want optimized Rust code, you're going to need -- release, and you might also want to strip out debug information. If I run this, it should just work as well. And I'll drop by that. Oh, as you can see, we have 100% Rust code coverage, which you can put this up on CI. All of these commands would still work on CI. It would still work on GitHub Actions, but you're going to need to put all these commands into the YAML file that gets run by GitHub Actions. And right now it has built a view, and as you can see, it has built the optimized Rust code. So you should be able to find that here as well. And look, it is only 475 kilobytes of Rust code, because our Rust functions are generally very simple. So if we run that benchmark again, let's see how long it will take. All right, so still about 6 seconds. All right, which is kind of about the same as the debug code. Oh, now it's 4 seconds. Maybe I should do it a couple of times to be able to see the correct answer. But there you have it. That's the idea, right? We are able to have Python that runs optimized Rust code. We have a demonstration repo here that allows you to use both PyPI and crates.io. And if I may just share my VS Code again. Okay, so cargo.toml allows you to specify the libraries. These dependencies come from crates.io. pyproject.toml over here allows you to specify packages that get installed from PyPI, and these are just optional dependencies for testing. All these are just testing tools. All right. However, my command installs all the testing tools by default, simply because in requirements.txt it installs them by default. So just feel free to change these, fork the repo, and change these to your liking. All right. The only caveat in my demonstration is I think I hard coded this file name, so you may be able to find out how to rename that. And I think that's located in truncate.py. So truncate.py has this particular file name that's hard coded, so feel free to change that. All right, so I'm coming towards the end of my presentation. Let me switch back to my slides first. Present. So thank you. And once again, feel free to contact me. I'm Gary Kwong. I'm a principal at YGit Software. You can contact me at gkw@ygitsoftware.com, or you can find me on LinkedIn. I love to talk. Basically, I'm fluent in English, Cantonese, and Mandarin. And talk to me, and I'll be able to try and help you figure out if this is a possible way forward to help you. I'm basically available for more work going forward. Let's look at whether there are any questions. Feel free to ask any questions. In the meantime, thank you. And while we wait for questions, Sammy, I think you'd like to add on some more items.
Yeah, thanks, Gary. So may I ask a question? So, before people use words, some people use C in the Python project. So, what do you advise them to switch from C to words in Python project?
Okay, good
What's
question.
the benefit? Yeah.
What benefit? Well, if your C++ code works well, it has no security issues. There probably isn't much incentive to go over right now. However, if you're constantly changing your C++ code, if you're always adding in new stuff, and if you foresee your Python code in your project being just a bootstrapping language, it's something to start you off very quickly, but Python's performance is not good enough, so you want to move to another language that is more performance oriented, like C, C++. In my demonstration here, I'm just proposing that Rust can be a way to fix your Python problems while avoiding some of the security issues for C++. If your C++ code, you're not going to change it, and you know there's no security problems, fine. That's no need for you to switch, I guess. But if you foresee yourself writing more performance-oriented code that's not in Python, but you still need the bridge to Python, you might want to do it in Rust going forward. The incentive is the testing frameworks, the documentation frameworks, the code coverage frameworks. They're all available in my demonstration. You don't have to set them up separately. And by only writing safe Rust code, you do not have to worry about entire classes of C++ problems as well. Finally, you'll be able to hire for the right people. Generally, a good C++ and good Rust developers tend to command a higher salary than Python developers. You may also want to see how much talent is available in your city. And having this choice is I think it's a good way forward. It depends from company to company, right? And having this choice allows you to be flexible going forward. Right?
Yeah. So in the daily life, when we do some Python application development, we always use a lot of Python library from PyPI. So I hope that many of them will use what's in their Python project. So the security of the Python package will be improved. Yeah.
Right. That is true. And with this demonstration, you have seen how you're able to integrate a package from crates.io, and you're just able to use it in your Python setup just like that. Yeah.
Okay.
So does anybody in the audience have questions?
No, I don't think so.
Oh, we good?
So yeah, thanks for Gary to giving a talk to share how to use what's in a Python project. So after Gary presentations, I will have some promotions about the PyCon Hong Kong. Yeah. So So let me share my screen. Okay. So PyCon Hong Kong will be host in 11 November Saturday in Kobe Bay. So it's very easy to access from MTR from MTR. So you can share from the PyCon.hk as well as our Facebook page for PyCon.hk. And and also so uh, so you can find the ticket information here. So when you click ticket tab here, so you will be direct to the event by to get to purchase a ticket. And if you have some difficulty to afford a common ticket, so you can apply financial assistance program as well. So the link is also in the UMBI as well. So you can find it here as well. So for the new Python learner and also experienced Python coders, so we hope that you can join the PyCon Hong Kong in November. So we have some overseas and local speaker to share about some Python topics and AI and machine learning, and also Web3 and IoT as well. So just like for example, you will meet Lady Tokyo, so they will have a representative to share about Ladies communities, and also with fast graph and analytics with Python and Web3, MySQL, and LM LLM deployment in Python, and some Cantonese topic as well to share點樣去玩轉 Python 同埋 JavaScript 啦，these Cantonese topics, and also we have some just like how to automate business tasks with language change and Python and Python as well. And also we have IoT projects, and also have generative AI with Python as well. So you can find many good topic here. Actually, our conference is a two-chess full day conference. So so we hope that to see you in the PyCon this year. So we also have some promotion offer as well. So I show it on the bottom here. So so we have 10 complimentary conference ticket promotion code. So you can get a free ticket, only 10 tickets, valid in 1 hour from this line. So and also we have a 50% discount off promotion code as well, always HK 1019. So and the promotion code for the free tickets should be, let me see, this coming SOWMMNE5. So it only valid in 1 hour only. So we hope to see you in PyCon PyCon Hong Kong this year. And last but not least, we would like you to comment, like, and share Open Source Hong Kong YouTube, Facebook page, and Meetup as well. And check out our website, opensource.hk. Yeah. So you can find our latest events and also some information about open source community in Hong Kong as well. Yeah, so this is the end of this webinar. So we hope to see you in next webinar and PyCon and other in-person event as well. See you